Hello, sixth graders. Today this is Mrs. Brinkley and I am talking to you about how to use a number line to multiply and divide integers. You're going to need this page. This is going to be your independent practice page. I am going to use this page to do some notes, and we are also going to need our notebook. When we talk about integers, a lot of times we forget some of the things that connect to our thinking. Our new information really relates back to something that is old to us. It's fact families. Now, fact families just means that I can use the same numbers in multiple ways to make true mathematical sentences. So this says 3 times 4 equals 12. Now, the commutative property that we talked about last week says that 3 times 4 can be switched, because multiplication, if I change the order, does not change the product. So if I have 3 times 4 equals 12, then 4 times 3 is also equal to 12. Now, multiplication and division are the inverse operations. So if I take my 12 and I divide it by 3, I'm going to get my other factor that was up here, 4. And in the same way, 12 divided by 4 is equal to 3. And this is what we call a fact family. So I'd like you to pause for just a moment and try this fact family on your own. So I gave you the first one, which is 5 times 3 equals 15, and see if you can complete the other parts of that fact family before we move on. All right, great work. Let's see if you came up with the same thing I did. I have 5 times 3 equals 15. 3 times 5 equals 15. 15 divided by 5 equals 3. And 15 divided by 3 equals 5. So we're going to take this problem and we're going to transition over to this page. What do you notice about this problem? 5 times negative 3 is a whole lot like 5 times 3. And they kind of look like they could be related in the same fact family. So what I would like to do is talk about how this can relate to your fact families. So 5 times negative 3, just like we did with the counters, this still means 5 groups. And it means 5 groups of negative 3. So if I start at 0, here's 0. 0 can be in the middle, it can be to the right, it can be to the left, any way you want to, but 0 is where I want to start. And I need 5 groups of 3 negatives. Well, I know that the negative direction is to the left and the positive direction is to the right. So I'm going to start and go negative 3, 2 groups of negative 3, 3 groups of negative 3, 4 groups of negative 3, 5 groups of negative 3. And then I can kind of skip count. I'm going to do negative 3, negative 6, negative 9, negative 12, and negative 15. So 5 groups of 3 negatives is negative 15. So negative equals negative 15. So when I look at this model, what I hope that you understand is that this model can represent multiple problems. So this model represents 5 times negative 3 equals negative 15. Because I have 5 groups and negative 3 inside of each group, and I end up at negative 15. Now, my commutative property does not change because of integers, so I can also switch this around and say negative 3 times 5 also equals negative 15. So this model still shows my negative 3, and it still shows my 5 groups, so this is also represented in this model. Negative 15 divided by 5. Now remember, division is the inverse, so it's part of my fact family. Negative 15 divided by 5 equals negative 3, is also represented by this model. And negative 15 divided by negative 3 would also equal 5. All 4 of these number sentences, all 4 of these equations can be represented by this one model. So what we're going to do is we're going to try the next one using the same language we did with our counters. And this is negative 4 times 3, which means the opposite of 4 groups of 3. So if I'm imagining what 4 groups of 3 looks like, I can also imagine what the opposite of that would be. Well, 4 groups of 3 would be starting at 0 and 1, 2, 3, 4 with 3 in each one. 3 times 4 is 12. But I have to do the opposite of that. So here's I know that I'm going to move to the left because this one moved to the right. So we're going to move the opposite of 4 groups of positive 3. We're going to move 1, 2, 3, 4 groups of negative 3. So this is the opposite of 3, the opposite of 3, the opposite of 3, the opposite of 3. And that is negative 3, negative 6, negative 9, negative 12. So again, my fact families tell me that this can be representing multiple equations. It could represent negative 4 times 3 equals negative 12. It could represent 3 times negative 4 equals negative 12, which again is just that commutative property. Negative 12 divided by negative 4 equals 3. And negative 12 divided by 3 equals negative 4. So when you're presented with a number line model, the number line can represent multiple facts. Where I really get into trouble is when I have 2 negatives. So this would be the opposite of 6 groups of negative 2. So if I just look at this, 6 groups of negative 2, I want to do the opposite of that. So I'm not going to do 6 groups of negative 2, I'm going to do 6 groups of positive 2. That's how we do it when the first number, when the first factor is a negative, we're going to have to do the opposite of whatever we're looking to do. So 6 groups of negative 2. So here's 0, 1, 2, oh, yeah, we're going positive 2. 6 groups of positive 2. 1, 2, 3, 4, 5, 6. And that's positive 2, 4, 6, 8, 10, 12. So negative 6 times negative 2 is positive 12. Again, multiple fact families, multiple equations in the same fact family. So negative 6 times negative 2 equals positive 12. Negative 2 times negative 6 equals positive 12. 12 divided by negative 2 equals negative 6. And 12 divided by negative 6 equals negative 2. Oh my goodness. All of that work and you couldn't even see it. The next one, the last one before we move on to your independent practice, this one is a model that's already done for you. And if you notice, it starts at 0. What direction does it move? It looks like my arrows are pointing to the negative direction. So I have 2 groups because I have 2 sets of arrows. And I also have negative 2 inside of each group because I'm moving 1, 2 jumps. 2 groups of negative 2. And then equals negative 4. So again, there's fact families here. We can write this multiple ways. I can write 2 times negative 2 equals negative 4. I could use the commutative property and switch my factors to negative 2 times 2 equals negative 4. Or I could use my division and do negative 4 divided by 2 equals negative 2. Or negative 4 divided by negative 2 equals positive 2. So I hope that you're able to look at the number lines in a new way and be able to see that one model actually represents a lot of different ways to solve a problem. So you're going to be doing this one on your own, but I am going to go through and work through the first 2 problems with you so that you can see what the expectation is. It says write out the verbal description for each expression, model, and solve. So this one is 3 times 6, and we would still write 3 groups of positive 6. So I'm moving 3 groups in the positive direction, which is to the right. So I'm going to go positive 6, positive 6, positive 6. So 6, 12, 18. So 3 times 6 is 18. And by now I'm hoping that you're able to see that this model represents more. See if you can challenge yourself for each one of these to write at least one part of the fact family. This is a number line that's already done for you. And I want you to write at least 3 equations that this model could represent. So I'm going to start out by writing some facts. I noticed that there are 2 groups. And each group has 1, 2, 3, and it looks like it's moving to the negative direction. So it's 2 groups of negative 3, and I end up at negative 6, which tells me that 2 times negative 3 equals negative 6. Well, I have to remember that commutative property tells me that if 2 times negative 3 equals negative 6, then negative 3 times 2 equals negative 6. Now, I didn't say you have to do 4, but you could do 4. I said at least 3 equations. So my third equation is going to be negative 6 divided by 2 equals negative 3. And I'm going to write the fourth one, negative 6 divided by negative 3 equals 2. Now you have 6 more problems to try on your own before you start working on your IXL practice. There are 6 problems, and you can check your work and then you move on to practice. Thank you.